To find the volume of the solid after a cone has been removed, we first find the total volume as if it were a full cube. So area of the base is 6 times 6 is 36, and then you multiply the area of the base by the height of the cube. So the cube is 216 centimeters cubed, and since we're taking out the cone, we need to know what the volume of the cone is. Formula for volume of a cone is 1/3 pi r squared h. So the diameter is 4, meaning the radius is half of that. And the height, well, the cone is the same height as the cube, so the cone has height 6. Okay, so multiplying all this together, we get 8 pi. So the total volume, we started with 216, but then we cut out a cone that had a volume of 8 pi. Five cubes with sides of 5 centimeters. So let's just work with one cube first. So cube means length, width, and height are all the same. So one cube has a volume of 125 centimeters cubed, but we have 5 cubes. So we take the volume of one cube and multiply it by how many we have. Okay, so we have 625 centimeters cubed of metal to work with, and it gets melted and reformed into a sphere, so that means the volume stays the same because we have the same amount of metal as before. So volume of a sphere, formula 4/3 pi r cubed, and in this case we need the volume to be 625. So now we solve for r. First, I'll get rid of the 4/3 by multiplying both sides by 3/4. And then divide both sides by pi. Okay, so that gives us radius cubed equals 468.75 over pi. So I can simplify. Okay, but this is radius cubed. We want regular r. So we need to do the cube root of both sides. So every calculator is different. For this calculator, for any root, I type in 3 for cube root, second this button. So I want the cube root of approximately 149.2. And I get radius is approximately 5.3. Identify the conic. I see both x squared and y squared terms, so I know it's going to be a circle. I know for circles, x squared and y squared have to have coefficients of 1, so I'll divide both sides by 2 to start. So I want to get all the variables on one side and all the constants on the other. So I need to get the y squared and the 2y to the left. And then I need to get rid of this 37 and move it to the right. So continuing over here, I've got x squared minus 12x plus y squared minus 2y equals 16 minus 37, which is negative 21. So for a circle, I know my goal is to end up with something that looks like this. This is standard form of a circle. So what fills in the blank is always half of the coefficient of that variable to the first power. So half of negative 12 is negative 6. But I know that when I create a negative 6, I already have the x squared minus 12x that I need. But negative 6 squared means I have to create an extra 36 out of nowhere. So since I created on the left side, I will also have to create it on the right side. Same thing for the y's. Half of negative 2 is negative 1. So I've already got the y squared and the minus 2y I need, but negative 1 squared means I need an extra plus 1, so I also add plus 1 on the right. So on the left side, negative 21 plus 36 is 15, plus 1 more is 16. Okay, so here's standard form. And label the key features. So I can read the center off the standard form equation. It's the opposite of what it looks like. So this looks like negative 6. This looks like negative 1, so it's really positive 1. And then remember that this is r squared, not r. So if r squared is 16, that means that r is actually 4. So center at 6, 1, and radius of 4, so I go 4 in all directions. This is a parabola because there's an x squared term but no y squared. So standard form, I need the y by itself. Okay, key features. So first I'll find the vertex. I know the x coordinate of the vertex is always equal to negative b over 2a. So in this case, b, the coefficient of x, is 2. So negative b becomes negative 2. A is the coefficient of x squared. So here, a is negative 1. So simplifying, I get negative 2 over negative 2. So the x coordinate of the vertex is 1. So now I need the y coordinate. Well, if x is 1, I can calculate y by plugging in. So 1 squared is 1, then you stick on the negative. So it looks like y equals negative 3. Okay, so to find the focus, we need to use the formula. Distance from vertex to focus is 1 over 4a. And in this case, a, the coefficient of x squared, is negative 1. Okay, so we get negative 1/4, but we just care about the absolute value. The distance is 1/4, and now we need to decide which direction the focus is from the vertex. So since a is negative, that means that the parabola opens downward, and the focus is always inside the parabola. So in this case, the focus is below the vertex, and it's 1/4 of a unit away. So since the vertex is at 1, negative 3, That means that the focus, it's in line with the vertex, so it also has an x-coordinate of 1, but the y-coordinate is 1/4 of a unit lower. So -3 1/4. And then the directrix is an equal distance away from the vertex, but it's the other direction, so the directrix is always outside the parabola, and it's a line with equation y equals, and it's 1/4 of a unit above the vertex. So we look at the y coordinate, so 1/4 of a unit above -3 is -2 3/4. Okay, so circle has center 5, 6, so something like this, and tangent to the line x equals -1. Okay, so if the circle is tangent, that means it just barely hits the line at a single point. So I know that the point where it hits, it's in line with y equals 6, and it's on the line x equals -1. So looking at the coordinates of these 2 points, I can tell that the radius goes from -1 to 5, so the radius is 6 units. And then I just need to use the standard form of a circle. Okay, so h and k come from the vertex. H is the x-coordinate, k is the y-coordinate. Sorry, the squared should go outside the parentheses. And then r squared, well, if radius is 6, r squared is 6 squared, so 36. Equation of parabola with vertex 0, 1 and focus 0, 0. So see 0, 1. Okay, so this one we're going to want to use the vertex form of a parabola, which is this. So h and k, just like with the circle, represent the x and y coordinates of the vertex. So in this case, h is the x coordinate of 0, k is the y coordinate of 1, and all we need to do is figure out a. So we're going to use the formula distance from vertex to focus equals 1/4a. So in this case, we don't know what a is, that's what we're trying to figure out, but we do know the distance between the vertex and the focus. We can see that they are 1 unit apart. So I substitute 1 for the left side, I keep the right side the same, and now I need to solve for a. So first I'll get a out of the denominator by multiplying both sides by a. And that gives me a is 1/4. So now I just need to substitute that into the final answer. Okay, so normally this is where we would stop in vertex form, but in this case, x minus 0, we can simplify that. Given MA and NA are tangents, so one property is that tangents to a circle form perpendicular angles with their radii. So I can already see that AMO is a right angle of 90 degrees. Okay, to find x, we look for x on the diagram. We see it in 2 places, the circumscribed angle and the central angle that share the same arc. so the property we need is that those two angles are supplementary. They add up to 180 degrees. Okay, so again, the circumscribed and central angle add up to 180, so I just solve for x. Okay, so to find y, look for y on the diagram. This inscribed angle contains the variable y. So then I look for what is related to the inscribed angle. Well, its intercepted arc. Okay, so I should be able to find this arc from earlier because I already know that x is 20, so I substitute that in. So angle MON is 140 degrees. And then if central angle is 140, its intercepted arc is also 140. Okay, but on the other hand, the intercepted arc is not the same as its inscribed angle. The arc is twice as much. Okay, so if the intercepted arc is 140, I have to divide it by 2, and I get that the inscribed angle is 70 degrees. So since the inscribed angle is 8y, and that equals a total of 70 degrees, I divide both sides by 8 to solve for y. Okay, and then angle, a measure of arc MN, I actually solved that earlier. Again, once we know x, you substitute it in to get the central angle, and then the intercepted arc is equal in measure to its central angle. Okay, here we have an inscribed quadrilateral in a circle. So the property we're going to have to apply here is that opposite angles are supplementary. Okay, so starting with x, well, angles B and D are opposites. So that means that their angles add up to 180. Okay, so since I see 4/3 x, I'll switch 12x to have a common denominator. So 40/3 x, and then I'll add 20 to both sides, equals 200. Multiply both sides by 3. 40x equals 600, and then divide both sides by 40. Okay, to get y, I'm also going to use the property that opposite angles of an inscribed quadrilateral add up to 180 degrees. Okay, so if 9y equals 90, that means that y equals 10. Okay, true or false, the measures of angle CAB and measure of arc CB are supplementary. Well, let's call measure of angle CAB x because we don't know what it is. Well, the property we do know is that a circumscribed angle and the central angle that cut off the same arc are supplementary, meaning they have to add up to 180. So if this is x, I've used up x out of the 180 degrees, so there's 180 minus x degrees left over for the central angle. But then the central angle is equal in measure to its arc. So that means the arc is also 180 minus x. So yes, x plus 180 minus x does get us back to 180. Inscribed angles on a diameter measure 180. If false, provide a counterexample. Okay, so here's a diameter, meaning it goes through the center. And here's an inscribed angle on it. Okay, so the property we learned is that inscribed angles on a diameter are always 90 degrees, but as a reminder why, this half of the circle, we know half of a full circle would be 180 degrees. And this inscribed angle on a diameter that cuts it off, we know that inscribed angles are half of their intercepted arc. So half of 180 would be 90. A chord drawn perpendicularly through a chord will go through the center of a circle. Okay, so here's a chord, and let's say that here's the center. So it's sometimes true, but not always, because if I draw another line right here, it can be perpendicular, it can form a right angle without going through the center. Okay, so this would only always be true if it not only is perpendicular, but it's a bisector, meaning it cuts the other chord in half. Okay, so if I want to cut the first chord using a perpendicular bisector so that the two pieces are equal and it forms right angles, then it would always go through the center. Okay, used for finding the incenter. So remember the incenter, if you have a triangle, here's the inscribed circle that fits perfectly inside. So the incenter is an equal distance away from all three sides of the triangle. So the example that we used in class was the fountain that's getting installed in the park. That needs to be an equal distance from all three streets. Since each street is a line, the incenter would be an equal distance from all of them. Okay, the circumcenter. So remember, circumcenter, just like circumference means around, that means the circle goes around the triangle. So this is a circumscribed circle. And here's the circumcenter of this one. So the circumcenter is an equal distance from all three vertices. So the example we used in class was the tutoring center that wants to be an equal distance from all three high schools. So here the high schools are single points, they're not lines, which is why the circumcenter would be useful in this case. Okay, so we've got a circle here, but we're only concerned with this slice of it. We're given the measure of this angle is 3 pi over 4. And since there's no degree symbol, I know we're using radians, and the radius is 13. Find the length of the intercepted arc. Okay, so our general strategy has been find the full circumference and multiply it by the fraction of the circle we actually have, and that gives us the partial arc. Okay, so in this case, the full circumference would be 2 pi r. In this case, r is 13. Okay, now what fraction of the circle do we have? Well, the angle we have is 3 pi over 4. And what's that out of? Well, the full circle in radians is 2 pi. Okay, so we've got a fraction within a fraction, so we should simplify this. So fraction bar means to divide, and I'll just say it 2 pi over 1. And to divide fractions, we multiply by the reciprocal of the second number. Okay, so the pi's cancel out and we get 3/8. So this angle represents 3/8 of the whole circle. And just by looking at the picture, we can see that seems reasonable because 3/8 is a little bit less than 1/2. Okay, so let me just rewrite this. The full circumference would have been 26 pi, but we only have 3/8 of the full circle. So multiplying it together, we get, we can reduce this, 39/4 pi, and the units are feet. Okay, find the area of the sector. So same thing, we first find the full area, then we would multiply by the fraction of the circle we actually have, and this will give us the sector, which is the part of the circle we care about. Okay, so the full area formula is pi r squared. In this case, r is 13. Okay, so what fraction of the circle do we have? Our angle is 3 pi over 4. And that's out of the full circle in radians, we know is 2 pi. So simplifying this fraction, we multiply by the reciprocal of the second number. Okay, so we get that the fraction of the circle we actually have is 3/8 of it. Okay, so let me just rewrite it over here. The full circle would have been 169 pi, but we only have 3/8 of that full circle. So that means the area is 507/8, and the units are feet squared.